In the last lesson, you'll notice we focused on adding and subtracting polynomials, so those are the problems that are included on the bell ringer today. I'm going to go through those quickly as they then lead into multiplying polynomials. So on number 1, again, we talked about always looking right here to see whether this is addition, subtraction, or if it's put all the way together, there's no addition, subtraction, then it means multiplication, which we'll look at today. So if we start to combine these, again, this is just addition, which means we find the like terms. They must have the same variable and number of variables, so variable exponent. So if we have 6y and we subtract 7y, we end up with negative 1y, or just negative y. And then we have 3 plus 4. Gives us negative 1y plus 7. Number 2, again, this one's subtraction, so we want to take care of the negative before we start combining like terms. This is going to be negative 4d when we multiply that, and then if we multiply the negative back to negative 1, that becomes a positive 1. Once I do that, I'm going to ignore the original so that I combine the correct terms. Then I have a negative 3d, a negative 4d, so if I combine those through addition, I have negative 3 plus a negative 4 is negative 7d. And then I have 2 plus 1, which would give me 3. Same idea on the next one. We distribute in the negative, which would give us negative n squared. Negative times a negative 2 is positive 2. And that negative times a positive 3n would be negative 3n. Again, I'm going to scribble this part out just so I don't go back to it. Then we combine our like terms. So in this case, we have an n squared. Subtracting an n squared, so those add to 0, or in other words cancel out. We have a negative 2n minus 3 more n gives us negative 5n, and then we have 1 plus 2 would give us a plus 3. Okay, and then this last one leading us into what we're going to work on today. So this is distribution, we're multiplying, right? So we multiply the 10 in and we get 10 times 2x is 20x. 10 times negative 3 gives us negative 30. And this would be our simplified polynomial. So today our goal is to multiply polynomials. So we're going to use what we know from the past to then build on larger polynomials this year. So each term, when we distribute, right, of the first polynomial, this is the rule, must multiply to each term in the second polynomial. So remember, terms are split by the positive and negative signs, plus or minus, and we want to combine them and then write them in standard form. So let's start with number 1. Again, this looks a lot like number 4 on the bell ringer. We distribute in, we multiply the negative 4 times 2x and get negative 8x. We multiply the negative 4 times the positive 1 and get negative 4. Now that's the end because there are no like terms to combine, and that was just a monomial times a binomial. So everything multiplied by each other. Same thing with the next one. We have a monomial. The only difference is this one has an x. So when we multiply 3x times 7x, the 3 times 7 becomes 21, and x times x is x squared. We then multiply the 3x by the next term, negative 5, which gives us negative 15x. As we continue to do this, no matter how big this polynomial becomes, we just continue to distribute. So we take this monomial and we multiply it by each of the 3 terms. Now there are 3. So 2x times x squared would just be 2x to the third, or x cubed. 2x times x is going to be 2x squared. Then 2x times negative 6 is negative 12x. Lastly, notice this one's a binomial times a binomial, so we're going to distribute, but when we do that, again, we have to follow the rule. We take each term of the first polynomial and distribute it. So there's the first term distributed. If we do that, we get x times x, which is x squared. We then get x times the 5, which is 5x. Then we make sure that this second piece of the first one multiplies by each piece of the second one. So we get 2 times x, which is 2x. And 2 times 5, which is plus 10. Once you've multiplied out larger polynomials, there will often be like terms. Notice this 5x and this 2x can combine, just like we did in the last lesson. So x squared stays as is. There's no other x squareds to combine with. And 5x plus 2x is 7x. and then that 10 comes down. So we finish with our polynomial written in standard form, right? The highest exponent goes first, and then the x value, and then the constant, so no x value. This is often termed or referred to as foiling in mathematics, but it's really just distribution. It's just another term. People say FOIL it, and it means multiply it together. When they talk about that, it's this F stands for first, and when we say first, we're just talking about the first term multiplied by the first term. So we go first times first, just like we did with distribution. Then the O stands for outside, so this and this are considered the outsides of these two binomials, so that's what multiplies second. And then we do the inside. Oh, that's a double I, it's fine. So we do, again, the B times the C. Those are the two inside pieces, and then we do last times last. Again, it's just a distribution, but it's the order in which we're distributing. So we're just going to practice a number of these quickly. I'll do a few together, and then I would pause and try to do some on your own, and then check back with me. So if we start on this first one, again, we're just distributing. If we're foiling, we do first times first, right? X times x is x squared. X times 3 is a positive 3x. 7 times x is 7x. There's my inside pieces. And then last times last is 21. Again, once you've multiplied or distributed through, 3x plus 7x, those two can combine. So I've got x squared in the front here. 3 plus 7 is 10, and they both had an x, plus 21. Next one, very similar, but there's negatives involved, so don't lose track of your negatives. So we start again distributing first times first. We get x squared. Then we do x times 6, and we get 6x. We then distribute the negative 4. Again, it's a negative 4, so negative 4 times x is negative 4x, and negative 4 times 6 is negative 24. When we combine those in the middle, right, 6 subtract 4, we get x squared, and then 6x minus 4x is positive 2x, subtract 24. Again, here on the end, we do the same thing. We've got 2y, and we're multiplying it by a y, so that would be 2y squared. Then we do the outside, so 2y times negative 4 is negative 8y. We do the inside, 3 times y is positive 3y, and we do last times last, which would be negative 12 in this case. Again, we look at those middle pieces as those are like terms, and the first term stays the same. Negative 8y plus 3y is negative 5y minus 12. Okay, these ones down here at the bottom are the same idea. Go through and see if you can multiply those, so maybe pause the video. When you do, you should end up with m squared minus 2m minus 3 as your final answer. So again, walk through and do that multiplication first. And this last one, you would get 3n squared plus 28n plus 9. As we look at the next page, this is the same idea. This is just another way to organize it. So for some of you, the box method might be most helpful. With the box method, all it is organizing it in a way that allows you to keep your pieces organized. Anytime we use a box method, we look at the types of polynomials we're multiplying. In this case, we have a two-term or a binomial times one with also two terms, another binomial. So we've created a box that is a 2 by 2. One polynomial goes along the left side, so we have r here, and the other term is 5, so each term gets its own row. The other polynomial goes along the top, so 2r gets its own column, and negative 3 gets its own column, and don't forget about those negatives. We then multiply to fill in the box. So when you're filling in this box, right, that comes from this column and this row, so we multiply these two pieces. We multiply r times 2r, which is 2r squared. Then we move to the next box, and to fill this box in, we multiply again the r times the negative 3. That would be negative 3r. And we do the same moving down to the next row. We would multiply the 5 and the 2r if we want to fill in this box. That would give us 10r. And 5 times negative 3 allows us to fill in the last box. The box is really nice because you'll notice that on this diagonal here, you now have your like terms to combine. So once your box is filled, your multiplication is done, and we just want to write this in standard form. So we're going to start with the greatest power, the 2r squared. We then combine 10r, subtract 3r would give me 7r, and then we subtract the 15. That would be standard form. Again, I'm going to go through one more. If I have a 2 by 2, I build a table that has 2 rows and 2 columns. One of them goes on the left, so for x, don't forget that negative needs to come with the 1, and it gets its own row. Then up at the top, we put in 2 and negative x. We then multiply. So again, we fill in each box one at a time, so 2 times 4x would give me 8x. I then multiply negative x times 4x, which is negative 4x squared. I then keep multiplying here. 2 times negative 1 is negative 2. And negative 1 times negative x would give me a positive x. And I'm going to put 1x to help me remember there's one of them. Again, notice on your diagonals here you have the 8x and the 1x. If ever your diagonals are not like terms, maybe take a step back and look and see if your multiplication was correct or not. Then we pull things out. Again, I'm going to start with this one because this is the highest exponent. So I'm going to do negative 4x squared. I then combine the diagonal terms, so 8x plus another 1x is 9x, and then minus 2. And again, the goal is to keep track of those negatives. That's the tricky part. Alright, go ahead and try it on the next one. Again, you can pause and work through that. Go ahead and build your table. In the end, you should end up with p squared minus 5p minus 24. Alright, lastly, again, the polynomials are just getting bigger. Either method works for these, and I just want to show you that both methods work. You're welcome to choose whatever method you like. Again, we have a binomial multiplied by a trinomial. So we're going to take the first term here, and he needs to multiply by each piece of the next polynomial. X times x squared gives us x cubed. X times negative 3x is negative 3x squared. And x times negative 2 is negative 2x. Again, very common for those exponents to decrease as we move to the right. If you keep getting the same exponent, again, look back at your work and make sure we're not missing something. Then we do the positive 5 by each piece of the trinomial. So 5 times x squared is a positive 5x squared. 5 times negative 3x is negative 15x. And 5 times negative 2 is negative 10. If you have any like terms, you then combine them. Again, the x cubed, he's the only cubed piece, so it'll stay out front. We have a negative 3x squared and a positive 5x squared. So when we combine those, we get 2x squared. We have a negative 2x and a negative 15x. Those combined give us a negative 17x, and then we bring down that negative 10. That guy's in standard form, and that would be our final answer. Now, the next one is exactly the same problem, but notice you could organize it a little differently. There's 2 rows because the first is a binomial, so 2 terms. Then we have 3 columns because we're dealing with a trinomial. Again, this is actually identical to the problem on the left, so we would just fill this in. X times x squared is x cubed. X times negative 3x is negative 3x squared. X times negative 2, negative 2x. The next row, 5 times x squared is 5x squared. 5 times negative 3x, negative 15x. And 5 times negative 2 is negative 10. Notice again those diagonals. Here's our x squared pieces, and if you didn't get x squared pieces on your diagonal, then you need to check back your work. That didn't make sense, but check back at what you multiplied. Okay, then we pull them out. So we get x cubed. Then we combine that first diagonal, the 5 and the negative 3, to get a positive 2x squared. We combine the negative 15 and the negative 2x to get negative 17x, and the negative 10 comes down on its own. Okay. On this last one, I'm just going to set this up in this box. Again, you've got a binomial times a trinomial, so you're going to need 2 rows and 3 columns. or 2 columns and 3 rows. And we're going to put 2m here and negative 3. Then we're going to put m squared, 4m, and a positive 10 across the top. The most common mistake with the box method is we try to start adding and subtracting early, so make sure that we're not doing that. So 2m times m squared is 2m cubed. 2m times 4m is 8m squared. 2m times 10 is 20m. Negative 3 times m squared is just negative 3m squared. Negative 3 times 4m is negative 12m. And negative 3 times 10 is negative 30. Again, there's our diagonals with our like terms. We've got squareds on that diagonal, and then m's on this diagonal. So as we pull it out, we've got 2m cubed. We combine those first diagonals. We've got an 8m squared on top, and then subtract that 3m squared to leave 5m squared. We then have negative 12m and a positive 20m, which is a positive 8m. And then we subtract the 30. That is multiplying polynomials.